Let's wrap up our look at the motion of the Earth by talking about seasons. Seasons are caused by a combination of daily and annual motions. You've probably already heard that the Earth is tilted. In fact, most globes are tilted to reflect this. But you might be wondering what that really means. After all, there is no table out in space for the Earth to be tilted on. So what is it tilted with respect to? In fact, the tilt is between the Earth's equator and the plane of its orbit around the Sun. In effect, the Earth's spin doesn't line up with its orbit. What this means is that in summer, the Sun at noon appears high overhead, while in winter, the Sun is low even at noon. When the Sun is high overhead, it warms the ground very efficiently. When the Sun is lower, the same amount of energy is spread out over a larger area, so it doesn't heat the ground very well. This is the mechanism that causes seasons, the angle of the Sun's light hitting the Earth. Distance is not a factor. One common mistake people make is assuming that the summer hemisphere is somehow tilted closer to the Sun, and that makes it warmer. But this is not the case. The tilt doesn't bring you closer in summer. It just makes the Sun get higher in the sky. It also means that your day is longer. Have a look at this diagram. It shows the relation between the Earth's orbit and the seasons. On the left, we see the northern hemisphere summer. The person in the north sees the Sun high overhead, so they are getting the full effect of the Sun's light. The one in the south has to look at a low angle to see the Sun. However, notice that they are at almost exactly the same distance from the Sun as the one in the north. On the other side, we're looking at the Earth 6 months later. Now the roles are reversed. This illustrates another important point. When it's winter in the north, it's summer in the south, and vice versa. Crossing the equator means that the seasons reverse. Also notice on the orbit diagram that the Earth's tilt doesn't change. The Earth doesn't flop back and forth in its orbit around the Sun. It keeps pointing in the same direction. It's just our motion around the Sun that causes the seasons to change. There are a few special points in the year that relate to the seasons. First off, we have the solstices. Solstice literally means sun still. These are the points of the year when the Sun reaches its highest or lowest point in the sky at noon. They mark the beginning of summer or winter. Note that the names have a northern hemisphere bias. So the summer solstice is in June when the northern hemisphere starts summer. The south is starting winter at that time. The equinoxes happen when we get equal amounts of day and night. This happens halfway between the solstices. The Sun rises due east and sets due west on these days. They mark the beginning of spring and fall. One other thing we notice about seasons is that they change the length of the day. More of the summer hemisphere is lit up, so a larger fraction of the time is in daylight. On the winter side, the Sun isn't up as long because less of the hemisphere is in daylight, so we rotate away from the Sun sooner. As we get closer to the poles, this becomes more extreme. Where I grew up in Vancouver, it was not unusual in winter to go to school before the sun came up, and if I stayed a little late, I might be going home in darkness as well. On the other hand, it could be light out until almost 10 o'clock at night in midsummer. At the poles, the difference in daylight between winter and summer is literally night and day. The winter pole is tilted away from the sun, giving 6 months of darkness. The summer pole is tilted towards the sun, giving 6 months of daylight, though the sun never gets high above the horizon. Instead, it just circles around the sky just like the stars do. At the start of spring, the sun pokes above the horizon for the first time in 6 months. This picture was taken at the Amundsen Scott Research Station at the South Pole. Since it's in the southern hemisphere, spring comes in September, not March. People here are stuck at the station all winter long. There is no way to get in or out. So when they see the sun come up in September, they have quite a celebration. Now we have the basic idea of seasons. Let's focus in more detail on what we experience from a range of different places here on Earth. Remember what we said. In addition to crossing higher in the sky, the summer sun is also up for longer, giving us more hours of daylight in the summer than the winter. In this picture, you can compare the hours of daylight on the summer solstice, June 21st, to the hours on the winter solstice, December 21st, by counting the hourly images of the sun on each path. Go ahead, pause the slide and make your count. Is the difference consistent with your experience? If you live anywhere near the latitude 20 degrees north or south, southern Mexico or the Caribbean, for example, this first picture should be familiar. If you live at a latitude of about 50 degrees, Vancouver or Newfoundland, the second picture will be more familiar. Pause and count again. Can you confirm that the difference between a summer day and a winter day is more extreme nearer to the poles? If you lived at 70 degrees, for instance, Prudhoe Bay, Alaska, you would live above the Arctic Circle. People who live there already know that they experience 24 hours of daylight at the summer solstice, as shown in this third picture, while at winter solstice, they don't see the sun at all. Before you go on to the next slide, think for a minute. What would you expect these pictures to look like if they were drawn for the equator, 0 degrees, or the poles, 90 degrees? So which diagram shows the sun viewed from the equator, and which shows the sun from the poles? If you need a little help, find the palm tree. Now for a bonus question. How many days of the year can the sun be directly overhead at the equator? At the poles? Remember that each picture shows the path of the sun for the specific dates of the solstice, not just for random days of the year. In addition to showing the path of the sun across the sky, these same diagrams can help us imagine the daily or nightly motion of any other astronomical object, because these motions also result from the Earth's spin. With this in mind, decide which diagrams best show the motion of the stars and the moon across the sky where you live. Remember that we define the part of the sky that does not rise and set as circumpolar. About how much of the sky that you see should be circumpolar? How much circumpolar sky would you see if you lived near the pole? At the equator? Now let's see if you can apply an understanding of seasons to another world. Here's a picture of Saturn taken back in early 2002. Although the view is actually from the Earth, you can treat it as if you are on the sun here, looking at Saturn. North is at the top of the page, and the rings are right over the equator. Also, it takes Saturn 29 years to go around the sun. Assuming that Saturn's seasons are divided up like the Earth's, into spring, summer, fall, and winter, what were the seasons on Saturn when this picture was taken? How long should the seasons on Saturn last? And lastly, what should the seasons on Saturn be now? Remember that you need to explain how the information given, along with this picture, tells you the answers.